The universe began in an incredibly hot, dense state. Since then, space has expanded, galaxies have formed, stars have been born, and planets have emerged. But nothing in the universe lasts forever. Stars eventually run out of fuel, galaxies change. Black holes may eventually disappear, and on timescales almost impossible to imagine, the universe itself could become radically different from the cosmos we see today. So what happens at the very end? Let's travel into the distant future and find out. 1. The universe has a future. When we look into space, we're actually looking into the past. The light from distant galaxies may have traveled for billions of years before reaching us. But the universe we see today is only one moment in a much longer story. Space is still expanding, and observations show that this expansion is accelerating. The mysterious force associated with this acceleration is called dark energy. Its true nature remains one of the biggest unanswered questions in modern cosmology, and it may determine how the universe ultimately ends. Number 2. First, the stars will begin to die. The first major chapter of the cosmic ending involves something much more familiar: stars. Stars shine because nuclear fusion transforms lighter elements into heavier ones, releasing enormous amounts of energy. But their fuel isn't infinite. Our sun, for example, will eventually exhaust the hydrogen in its core and dramatically change. It will expand into a red giant before shedding its outer layers and leaving behind a dense white dwarf. Across the universe, countless other stars will follow their own evolutionary paths, gradually reducing the number of bright stars in existence. Number 3. The era of the last stars. As billions and trillions of years pass, star formation will gradually slow. The clouds of gas needed to create new stars will become increasingly scarce, while existing stars continue consuming their fuel. Eventually, the brilliant stellar population of the universe could become dominated by long-lived red dwarfs, the smallest and most efficient stars. Some may shine for trillions of years, but even these extraordinarily long-lived stars are not eternal. Eventually, the universe could enter an era where new stars are no longer being born and darkness becomes increasingly dominant. Number 4. The universe enters the degenerate era. After the era of normal stars, the universe could enter what cosmologists call the degenerate era. Instead of brilliant stars, space would be filled primarily with stellar remnants: white dwarfs, neutron stars, and black holes. White dwarfs would slowly cool, while neutron stars would remain as incredibly dense remnants of ancient stellar explosions. If the laws of physics allow protons to decay, even ordinary matter could eventually disappear over extraordinarily long timescales. The universe would become darker, colder, and increasingly dominated by remnants of its once brilliant past. Number 5. The age of black holes. Eventually, black holes could become some of the most important objects left in the universe. They are created when massive stars collapse or through other cosmic processes, concentrating enormous amounts of mass into extraordinarily compact regions. But even black holes may not last forever. According to Stephen Hawking's theoretical prediction, black holes can slowly lose energy through Hawking radiation. For the largest black holes, this process would take an unimaginably long time, far longer than the current age of the universe. But eventually, even these cosmic giants could fade away. Number 6. The final black holes. Imagine a universe with no shining stars, no active galaxies, and almost no visible light. Only a small population of ancient black holes remains. Over extraordinary timescales, even these objects would slowly evaporate according to Hawking's prediction. Their final stages would release energy into an increasingly empty cosmos. If this picture is correct, the disappearance of the last black holes would mark the end of one of the most dramatic eras in cosmic history. But that still wouldn't necessarily be the absolute end of everything. Number 7. The heat death of the universe. Of all the possible endings, heat death is one of the leading possibilities under our current understanding of cosmology. Despite its name, the universe wouldn't become extremely hot. Instead, energy would gradually become more evenly distributed throughout space. Stars would disappear, galaxies would fade, and temperature differences would become incredibly small. Without meaningful differences in energy, there would be less and less ability for physical processes to occur. The universe could continue expanding forever, becoming colder, darker, and increasingly quiet. Number 8. Could the universe tear itself apart? But what if dark energy behaves very differently from what scientists currently expect? One theoretical possibility is the Big Rip. In this scenario, cosmic expansion would become increasingly powerful until gravitationally bound structures could no longer remain together. Galaxies would separate from one another. Eventually, smaller structures could be affected as well. In the most extreme version, even atoms could theoretically be disrupted. However, the Big Rip is highly speculative. Current observations do not show that this dramatic ending is inevitable. Number 9. Could everything collapse? The opposite possibility is known as the Big Crunch. Instead of expanding forever, imagine the universe eventually reversing direction. Gravity would pull galaxies closer together, cosmic structures would merge, and the density and temperature of the universe would rise dramatically. Eventually, everything could collapse into an incredibly dense state. For much of modern cosmological history, scientists seriously considered this possibility, but observations showing that cosmic expansion is accelerating have made a future Big Crunch much less likely under the standard model of cosmology. Number 10. Vacuum decay, the strangest possibility. Then there is an idea even stranger than the Big Rip or Big Crunch: vacuum decay. Some theories suggest that what we call the vacuum of space might exist in a state that is not completely stable. If a lower energy state were possible, a tiny bubble of that state could theoretically appear and expand through the universe at nearly the speed of light. Inside it, the fundamental behavior of particles could be completely different. There is currently no evidence that such an event will happen, making this one of the most speculative cosmic endings. Thank you for watching Science Decoded. If this journey through the possible fate of the universe fascinated you, make sure to like the video and subscribe. Which possibility do you find most fascinating? The heat death, Big Rip, Big Crunch, or something science hasn't discovered yet? Share your thoughts in the comments and join us for the next journey into the mysteries of science and the cosmos.